Welcome back, everyone. Today just going to kind of review a little bit in terms of naming and using these polyatomic ions. So use this as a supplement to what we do in class. So polyatomic ions, these are when you see an ionic compound. So you see a positive and a negative, you see a cation and an anion, and yet you see more than two elements. So we call these ternary or tertiary ionic compounds. So there's at least one polyatomic ion. So again, if you see more than two elements, there's at least one polyatomic ion in there. Use your cheat sheet. Make it easy on yourself. Again, just a little definition of polyatomic. Polyatomic ions are ions that are made of more than one atom that carry a charge. But again, these act as a group. They act as a single particle. You can't tear them apart. They're always going to be together. So if you need to add charge on one side, you got to add a whole polyatomic ion. So just some examples, but again, it works the same way. Polyatomic ions bond with elements of opposite charge. So the polyatomic ions are the ones in pink. So you have some hydroxides, which have a negative charge bonded with the positive. The one that I messed up is the only one that has the positive. Ammonia here, NH4, is bonded with the Cl, should be green. Maybe green, if it would let me. But that's the only positive one. You can see the rest of them. We can even have those transitions as well. So to name compounds with polyatomic ions, first just identify that you have more than two elements, and then go find the polyatomic ion on your handout. Again, make it easy on yourself. Use your cheat sheet. Number two, name the cation first, watching for transition metals, and then also watching for ammonia, because it is the cation. It's the only one. So name that metal. Use Roman numerals if you need to, if it's one of those special transitions. And then ammonia, just call it ammonia if you see it start with NH4. The third part then, name the anion. So again, this is usually your polyatomic as it appears in the handout. And then again, just watch for those transition metals. You might need to use Roman numerals. So let's say I'm pairing sodium Na plus and SO4 together. Well, together that makes Na2SO4. To name that, well, I would, first I see, oh, I got more than three. So I find my polyatomic ion, SO4, that's sulfate. And then I look at the first part, my cation, not a transition, so I'm just going to name it sodium. Name of the polyatomic ion, sulfate. Another example here, mixing these two things together. So I'm going to see this on my homework or whatever. So I look, oh, more than two elements. I got to have a polyatomic ion. Parentheses make it easy. They tell you here's the polyatomic ion. So OH is my polyatomic, but I'm looking for my cation here. Fe, that's iron. That's a transition. Yes, it needs Roman numerals, so I got to figure out charge. Well, if I have Fe and OH with a 3, make it easy on yourself. Your cheat sheet's going to tell you the charge of the polyatomic ion. So OH is a -1, and I have 3 of them. So -1 times 3 is 3 minus. Again, trying to play the game to get this to equal 0. So that means iron has to be a 3 plus. Divided by 1 means that each iron is a 3 plus. So when I go and name this, I'm going to call this iron 3. So again, iron 3, and then the name of my polyatomic ion is hydroxide. So I get to use Roman numerals here. Last one, mixing these two things together, this is what I'm going to see on my homework. Well, definitely more than two elements. So I'm going to have a polyatomic ion. Parentheses are going to show me here's my polyatomic ion. But then I still have more than two elements left over, or more than one element left over. So here's another polyatomic ion. I'm just going to use my cheat sheet. This thing, look at my cheat sheet, it's called ammonia. This thing on my cheat sheet is called carbonate. Put them together. Ammonium carbonate. A little mixed practice here. So name the following. If you're watching this and you can hear me, hit pause, try them. I'm going to show you the answers right now. So see if you can get those. Did you correctly identify the ones that needed Roman numerals? Did you use Roman numerals for only those ones? And also, did you correctly identify the polyatomic ions? So number one, well, that one wasn't even ternary. That was just a binary, 2 elements. The rest of them were, well, except number 3 and 4. So those were also, I only see 2 elements. I don't have to worry about polyatomic ions there. So did you correctly call this sulfide and nitride and oxide? So those are just things directly from your periodic table. Don't forget how we name the easy ones now that we know how to do the hard ones. Same thing down here at the bottom too, fluoride. That's going to be a trip up for people. All right, so doing the opposite. How do you write ionic compounds? So how do you write the formulas? How to write ionic compound formulas? So write your cation, write your anion, find your charges. If it's one of those A groups, one of the groups that we know the charge of, like sodium, we know it's always going to be a +1, or oxygen, we always know it's going to be a -2. Use those to help you. Go find your polyatomic ion on the cheat sheet. Roman numerals, maybe, if you have a transition. Do your crisscross applesauce. I guess about Roman numerals, if you see Roman numerals, say thank you, and then use it to write your charge of the positive. Do your crisscrosses then for your charges. Again, be a lazy chemist, don't write one. Use parentheses if you need multiple polyatomic ions, and then reduce your subscripts if you need to. That's really the steps you're going through every single time, for all compounds actually. Alright, so some more mixed practice. So to kind of follow my chart here, I'm looking, write the cation, write the anion. Okay, so write the cation, Cu, write the anion, chlorate. That sounds like a polyatomic. So I go and I look at my cheat sheet, ClO3 with a 1- charge. Oops. With the 1- charge. I'm going to use my Roman numerals to tell me charge here, copper 2+. I'm going to do my crisscross work. So I'm going to write a 1 here. I'm going to write a 2 here. So Cu. I'm not going to write the 1 though because I'm a lazy chemist. ClO3. And then I use parentheses with the 2 on the outside because I need 2 of these -1 charges to balance my 2 positives. So looks like that. The next one, calcium nitride. So write my cation, Ca, write my anion, nitride. Ends in IDE. 99% of the time that's going to come from just the periodic table. So nitride, there's no polyatomic ion called nitride, so that's just nitrogen. Write my charges. Well, these are both A group. So 2+, oops, 2+ and a 3-. Do your crisscross work. And this one, fairly simple, just put it together. Ca3 and 2 for your formula. The next one, aluminum carbonate. Again, polyatomic ion here because it ends in 8. So write your cation, Al3+. Carbon 8 from my cheat sheet. I go and find it, CO3 2-. Do my crisscross work. And I get Al2 CO3, but then I need a 3 as well, so parentheses to round that out. For the next one, potassium bromide, no polyatomic ion, so I'm just going to write that one. You can try it by yourself. That is KBr. The next one, barium fluoride, again, no polyatomics. So, and it ends in ide. Barium is just a normal element as well. So that one, BaF2. Try that one, see if you get it. Cesium hydroxide. We can do that one. So cesium, Cs. It's a first column element, so I know its charge is a 1 plus. Smartboard doesn't like that swipe. Hydroxide. Well, it does end in "ide," but I can find this on my polyatomic ions sheet. So it is a polyatomic ion. It is OH with a -1 charge. Crisscross, well, I can just shove these together. CSOH, or my answer there. Gallium hydroxide, go find gallium. It's a 3 plus charge every time. Hydroxide, we said, oh my gosh. Hydroxide, we said, is OH minus. Do your crisscross work here. This is one of those cases where if you're going to miss using parentheses, it's going to be for something like hydroxide. I want to put this 3 down here. Up here it's really obvious because I already have a 3. Down here though, I don't have a number. But again, I want to say I have 3 of this whole group. So again, I need parentheses. GaOH 3 for that one. Calcium carbonate, I think we did on the other sheet, or on a past slide. I'll just write the answer for you. CaCO3 for that one. 2 plus and a 2 minus, they balance, go right together. And then the last one, chromium 4 sulfate. So chromium 4, Cr4 plus. Sulfate is an SO4, 2 minus. I found that on my polyatomic ion sheet. Crisscross, 4 is going to come here, 2 is going to come here. Cr2, SO4, and I want to write another 4, well, parentheses. What's the issue? Well, I have a 2 and a 4. I can reduce that. So it's going to allow me to erase here. So Cr1, I'm not going to write it. SO4, 2 is my final answer there. So I'm not looking at that 3. So Cr2, or sorry, Cr SO4, 2. No space there. So I can fix that too. So put together nicely. All right, some helpful don'ts just to kind of, here's some things to watch for. So don't show charges in the final formula. Notice my final answers, no charges anywhere. Don't overuse parentheses. Notice I didn't use parentheses here or here. I only needed it when I wanted to show multiple polyatomics. Don't overuse Roman numerals. That's for naming. So notice here only a couple of them had Roman numerals because those are the only ones that have multiple charge. But also don't forget them either. You have to show that, hey, this is chromium 4 and not chromium 2 or something like that. So be careful there. And then again, don't forget to check charges. So make sure they balance. Crisscross does that for you. And then I guess maybe as a part of that also don't forget to reduce. So just some kind of things to watch out for as you go through these.